Okay, so this is episode number 3 of our discussion. So, tanawan na ito ang activity number 3. So, kung nakakita naman sa second video, I performed already the activity, which is entitled Small But Terrible. Part A, the mystery object. So, question number 1, after conducting the activity a while ago, kung nagtanong mo, nag-follow mo sa video, tuloy-tuloy naman eh. So, what is the shape of your mystery object? So, kung nakita mo ganyan sa akong drawing, so, balo naman sa answer. Question number 2, what is the size of the mystery object? So, draw a picture of the mystery object showing its size relative to the box. So, ito ang i-zoom. Sige, mga mata sa inyo. Okay. So, where is it located in the box? So, draw a picture of the mystery object. Show its location within the box. So, pwede nyo ibutang inyong drawing dito sa or the space there. So, pwede dito sa gilid. Drawing na mo dito o isa ka box. So, pwede nyo siya drawingan ang inyong activity sheet kung nag-avail mo. So, again, okay ginan siya ng ato ang activity sheet na ginabaligya sa inyo. Ang tinuod is na pajud na siya at ipajud na siya kanang pajud ako nabawi ang ako ang ipa-print ana. Yung na ako printer pero ang gasto sa ink, kuryente o papel di na printahan. Okay, balik ta. So, pwede ka mag-drawing ng box dali. Drawing mo itong kung ang i-drawing ka ganina. So, where is it located in the box? Draw the picture of the mystery box showing its location within the box. So, how are you able to infer the shape? So, sige, buhat na ako. Para ma-infer na ako. You mean by infer is, gusto ako pagkapaluk kung saan shape, ang size, ang location sa mystery object. So, itong gibuhat na ako. Ako nga siyang shake ang ito ang box. So, how close was your guess? And then, if given the chance to guess another mystery object, will you change your strategy? If yes, then what changes will this be? So, kung tagaan, na sa daw, kung masaman kaduol imuhang tag na dito sa actual jud na position sa object o size sa object o shape sa object. Na kung tagaan ta kag another chance na mag-guess na pod o another mystery object, isig buhaton nimo i-change man nimo imong strategy or the same ni happen. So, kung naka-i-change, isa mo po siya mga strategy ng change. So, muna siya ang question number 5. Sabtan ninyo? Dapat yun yung sabtan. Okay. Anyway, so let's go to part B. Okay. So, mag-pause na pagkuhaan nyo. So, we are going to kaya wala yung nanino kay ba si Dr. Strange yung pabalo na ako siyang gi-pause mga 5 minutes kay ni kaon sa kadali. Anyway, so tier 20 very small pieces of paper the size of mango beans, scatter the pieces in a circle on the floor about 1 foot in diameter. Imagine these to be the electrons. So, later, mapakita ko video about ana. As forcefully as you can, slide the coin to hit the circle of paper pieces. Imagine the coin to be the high-speed alpha particle in Rutherford's experiment. Mas pasa mo yan naabot ito. So, before data part B, magpakita sa video about Thomson's plum pudding model. So, i-pause na ako na yun. Ay. Pause na ako. Okay, so we're back. So, kindly look at this video. So, I will be playing this video later. This is what we call a cathode ray tube. This was used by J.J. Thomson. So let's go back to the PowerPoint. Models of the atom. So the very first model is the solid sphere model. It was proposed by John Dalton, a British school teacher, and he based his theory on others' experimental data. He did not conduct any experiment, but rather he just based his theory or his model on the experimental data of others. So, other term for solid sphere model is billiard ball model. So, if you're going to look at this one, so during this time, they're not yet aware about the existence of electron, proton, neutron, and of nucleus. So, for John Dalton, the structure of the atom is that it is a uniform solid sphere, just like a billiard ball. That's why he called this one a solid sphere model. Plain, no proton, no neutron, no electron, no nucleus. Just a sphere, solid structure. That's why he called this one as the solid sphere model. So, he viewed the atom as tiny, a solid sphere, or a billiard ball with no parts. After some time, the people accepted the theory of John Dalton and they believed about solid sphere model. So there was a time before that people thought of the atom as a solid sphere and no other parts until the time of J.J. Thomson that he created a new model, a new understanding of the atom, and he called this one as the plum pudding model or the Thomson's model of the atom. Plum pudding, not literally the pudding na ginapait niyo sa bakery na pudding, but rather kanang pudding siya na kanang jelly na ginakaon dito silang lugar. Ano yung mga raisins. That's why he called it plum pudding model because ang kadtong raisins, kani siya, he considered those raisins as the negatively charged electrons. Now, how did he come up with this kind of model? So if you're going to look at this model, the plum pudding model, it is not just a solid sphere, but rather it has a centralized positively charged region, and that the negatively charged electrons were embedded on it. Okay, so this is J.J. Thomson. The name of this guy is J.J. Thomson. So he used the cathode ray tube in order to perform some series of experiments, and that led him to discover the electrically charged particles, which later known as the electrons. So again, J.J. Thomson, kasi tawag sa iyang experiment, cathode ray tube experiment. And after the cathode ray tube experiment, he come up with the plum pudding model. So experiment muna bago ang model. So this is the example of a cathode ray tube experiment. This is a negative and a positive. So these are the cathode ray. Okay. So napansin niya na niduol ang cathode ray padulong sa positively charged na side, or positively charged na side. So na-attract siya dito sa positive. That nga kung duol po niya ang negative, mulayo sa iyaha ang cathode ray. So iya na conclude na ang cathode ray is consists of negatively charged particles. Let's watch the video. Okay, so this is a cathode ray tube, so let's watch it once again.
It's hooked up to an electric current, like I'm about to do here. You can see a beam moving across. You might think it's light, but when you take a magnet to light, does it do this?
So, igamit siya magnet.
Bending or deflecting.
So, negative side sa magnet. So, if you're going to observe, kasi nahitabo sa to ang cathode ray, di ba nilayo siya sa to ang negatively charged, negative side sa magnet. So, kung negative ni siya, so unsa to ang conclude about cathode ray? And we can say na kaning cathode ray is consists also of negatively charged particles. Kaya mulayo man siya. sa to ang negative side sa magnet.
Away from the magnet, so we know that it's not actually light. What J.J. Thomson summarized was that he was seeing a piece of an atom flying from one end of the cathode ray tube to the other, and that the piece of the atom that he was seeing was negative based on the end of the magnet that was causing a repulsion. So the negative ends of the magnet was causing a repulsion, therefore the particles must be negative.
Okay, so that was the experiment conducted by J.J. Thomson. That's why nakakonclude siya na ang kaning cathode rays consist of negatively charged particle. Dili siya empty space, dili siya empty. That's why he proposed this model that the atoms consist of positively charged matter, and then naa siya mga dagko kayo na electrons na naka-impede sa iya. So again, the name of the scientist was J.J. Thomson, and the name of the model is plum pudding model, based on the cathode ray tube experiment. So to summarize what plum pudding model is, so plum pudding model is proposed by J.J. Thomson. He said that negative electrons stuck inside and on the surface of a positive pudding. Atom's mass and the positive charge is widely spread. So we'll proceed to the next model, the Rutherford's model of the atom. Goodbye.